AI is moving fast, like scary fast. You've probably seen ChatGPT pump out essays, code, or even pass medical examinations. But here's the thing, that's just one AI working alone. The real knowledge and the real breakthrough isn't just in smarter single models, it's how they can all work together. Think about it like this. In the real world, nothing happens in isolation. A company doesn't run with one employee, it runs with a team. NASA didn't land on the moon with one genius. It was thousands of specially coordinated people. And AI is heading in the same direction, from single agents to multi agents. According to a McKinsey report, companies that use AI collaboration across multiple workflows see productivity boosts of up to 40%. That's just not a cool toy anymore. That's the difference between falling behind and dominating an industry. So in this video, I'm going to break down exactly why multi-agent systems are the next evolution of AI. And I'll show you one real simple world example, which hopefully you can relate to, of it evolving from a single agent to a multi-agent ecosystem. If you're new to the channel here, my name is Moise, and for the past half a decade, I've been advising C-suite executives on data and AI. I'm here to help you break down the fundamentals and concepts of AI and see how you can apply it for your business. Once you understand how multi-agent systems work, you realize we're not just talking about smarter chatbots. We're talking about the future of work, business, and even society. Okay, so now let's dive into an example where we can really show the evolution of AI. A scenario about a guy called John who wants to book in an appointment with the dentist. So we have an AI agent that can help us resolve some of this. And John, as a person who's booking an appointment, might want to just send them an email, coordinate on chat, or even phone them up directly. So we're going to use the evolution of AI agents with this given scenario. So this is an AI agent in its most simplest form. Now, John, who wants to book a dentist appointment, he might call the dental clinic and say he wants to book it for 9 a.m. on a Monday. And great, the AI agent might pick up the phone, and if 9 a.m. is free, John gets an appointment. But in reality, that's not what really happens. There's normally a bit of back and forth, sometimes some questions, sometimes a time slot just isn't available. And in these scenarios, this booking agent can't really do that well. I mean, it doesn't really represent reality, and it's good for one task. And this is how a lot of current agents operate. But we want to go beyond that. We want something that's realistic, something that's a bit more advanced. And we'll get onto that right now. This is our second phase with AI agent workflow. We don't just have one agent, we have many agents working towards the same outcome. So John still wants to book an appointment, but multiple agents work in series, and they each have their own sort of specialization, which represents something a little bit more realistic when you're calling your dentist up and they have an AI agent. So we've got a nice John character on the left. You go to a scheduling agent who would check whether the calendar is available. John needs to be made aware on his preferred communication channel. This could be an email that's being sent. This could be a text message, could be a WhatsApp. It could be all of the above. But John needs to be able to get that message and potentially get sent a follow-up reminder as well. So this is a series of events that takes place from when John requests it to when he can have the best customer service available to be able to know when his appointment is booked in. And it all works pretty seamlessly. But there are a few challenges which lie ahead. First challenge is this flow that we have above. It's going to struggle with complex content dependent tasks. So this is a slightly simpler workflow, but it can get to a point where there are a few challenges with this flow. In essence, it works pretty well to book an appointment, but once things start to get a little bit more complicated, maybe not in an appointment setting, but where there's a lot of dependencies going on, then that's something that can get quite difficult when it's working in series, because it can reach a certain point, a certain step, and then have to start all over again and go back to the scheduling agent from the beginning. And that kind of takes a bit of time and it's pretty inefficient too. Also, scalability and error handling. If there are challenges with one system and it stops, what will then happen, right? Will the agent just pause? Will nothing happen? Will it break down? That's a potential challenge. Conflict resolution. This is a big one. So let's say the scheduling agent is saying something that, I don't know, there's a time available at 9 a.m. on a Monday, but the knowledge agent is contradicting it with saying, this dentist, doesn't work on Mondays. So what's really going to happen there? And then you have a domino effect of no accuracy too. Let's say one agent has a success rate of 75%. Now, if you add another agent into that, the success rate drops to 56% because you're taking the error from the first agent and then multiplying it with the error from the second agent. So in these two scenarios, just with two agents, the success rate really drops. And as you add more and more, the likelihood of it being a success and getting the information that you need is pretty low. So you have 8 agents in total, let's say, and your success rate really just drops to about 10%. So the question is, how do we make this more efficient? How can we really fix this? The next scenario is going to show you the next evolution of AI, how multi-agents can all interact together in the right way, in the most efficient way to resolve some of these. And this is really the next horizon. So this third horizon is about the multi-agent orchestration workflow. So if there are multiple agents required to do a specific task, in this case, booking an appointment, rather than doing them in series and working in series, they can work all together in parallel in a much more efficient way. And it really stems from this idea of having one manager agent. You can call it an orchestration agent or whatever you like, but essentially it's the one coordinating all of the little smaller agents together. Think of it like a manager in a firm. You have one manager, a project manager, telling and coordinating lots of different stakeholders together. It's a similar concept, but just replicated into an AI agent landscape. In the scenario with John still is asking for a dental appointment, let's say at 9 a.m. on a Monday. But because you have all these agents working in parallel, the manager can decide what information from which agent they want to take. And if there is a conflict between 2 or 3 different agents, the manager can really resolve and decide, okay, that's the correct answer. Especially, let's say, with booking and scheduling, or the knowledge agent and the scheduling agent, the manager can have the source of truth really about what is correct. And altogether, that leads to a really happy John in the end, and he gets his appointment because it's a much more effective way for a customer to really seem like it's not really an agent that's talking to them. So that's it. So that's the big picture. Multi-agent systems aren't just a buzzword. They're the next leap forward in AI. Now, if you're curious about how this actually plays out in the real world, I put together a free guide with 50 agentic AI use cases that businesses can implement right now, no matter the industry. I'll drop the link below. It's completely free, so go grab it. And if you're a business that's ready to move from an idea into an action, that's what my AI agency does. We help teams design and build solutions just like the ones we talked about today. So if that's you, reach out. I'd love to hear how we can work together. Otherwise, thanks for watching. If this was helpful, hit subscribe and I'll see you again in the next one.